31 indication. And this one, right? We're gonna use this. And, this one here. Open widget and yeah, and yep. This and this and this and this one. And yes, YouTube. No. 37 and switch account to this one. Switch account to another one. Control T on YouTube. Yes. We should go to the account to this one and OBS number one. Yes, this one. And here, this. Oh no, yes. Alright. And yes, this one, and we're gonna check whether someone will join in soon. 35 by you do no, we have to your channel, and we're gonna see it soon. One, right? Oh my god, many people. Okay, and yes, this one. All right, and test 1, 2, 3. เทส1 2 3เทส1 2 3ครับไม่มีเสียงเทส1 2 3เทส1 2 3ครับไม่มีเสียงเลยoh my god test 1 2 3 and what happened 1 2 3อันนี้ก็ไปyes โอเค test เสียงไปอยู่นะครับโอเคก็จะเปิดไว้รอประมาณนี้นะ36 right internet doesn't go get done oh what happened right here right oh you're gonna leave it there but move the OBS okay MJ public education it's 38 39 okay I think it's time right now we need to start our lecture in SCI33205 which is physics number 4 this is the session for M604 right good afternoon everyone every student welcome you to SCI33205 the session for M604 okay we finished last lecture okay in this online classroom we are gonna use mainly English okay if you have any problem you may ask me immediately or stop me okay the YouTube channel there are 4 YouTube channels that are available in internet. You just you may watch it by where's that? No, we go to this is one of the channel. You can go to SCI33205. Okay, and another channel is right there. This one SK, and there are 3 live streaming in this channel. The first one here is by Streamlab. It's the mobile phone that looks at the iPad, and here is the Zoom to YouTube. That is the stream or the copy version from our Zoom classroom. If you don't want to join, you can watch the lecture in YouTube and just type your name in the comment section or chat in the YouTube channel. Another one, okay, there are 3 channels, I think. Yeah, there are 3 channels in YouTube. Another one is right here. Okay, you can see me immediately. Okay, there are 4 channels in YouTube. It's up to you. If you are comfortable with Zoom, just stay here. Just stay here. Okay. We have considered the application of the many people are going to join. Okay. Student number. This person, right? Eugene, number 6, right? Will be absent due to his activity. It's no problem. Just let me know. What is that? Good notes. Okay. I hope there will be no more person who wanna be absent out of the classroom. If yes, then please let me know somehow. I don't know. We still have a lot of lecture, right? Okay. We are in Thailand, and in Thailand, we have plenty of time for the sunshine, right? But in some countries, like in European continent and in the United States, in Canada, for example, they are even cold. In Finland, in Sweden, they have very less chance to see the sunshine. So another another artificial way to get the sunshine is that, okay, they build up the lamp, they create the lamp, and that lamp will emit the ultraviolet light. And yeah, this is I don't know the word in other countries, but as I have lived in Germany, it's gonna be called sunbath. Okay, sun, SUNBAD, bath, not bad in English. Sunbath means it is the place that you lay down and you can get the sunshine. It would be similar to this figure, but I have never attended or I got into that shop, so I have never been there actually, but I have walked around that shop. Okay, here you just take off your clothes and lay down on the bed, and there will be some lamps, and the lamps will generate the pseudo or the artificial ultraviolet light, and it's used for someone who want to enjoy the sunshine, but he or she lives in the place where no chance for the sunshine will be available. Okay, yeah, many people prefer indoor tanning to sun tanning because the rays of the sun are not uniform. Okay, it depends day by day, right? It depends on the atmosphere, the climate, and if you stay on the beach too long, okay, you will get burned and so on. And I got to know the owner of my building while once I was renting an apartment in Germany, and she would often go to Spain, okay, to lay down on the beach in Spain, and on her body there are a lot of small back points. I don't know the word in English exactly, but yeah, you will get something like that if you lay down on the beach too much, okay, too long time. Yeah, everywhere on her body, a small piece of black. Okay, yeah, that's the effect of sunburn. Okay, and the sunshine might not be uniform in some areas, so the people prefer the environment that can be controlled like this. Okay, they generate the ultraviolet light to go to the skin of a human. Okay, physicians may use tanning devices to treat skin condition, for example, psoriasis. Okay, and anyway, the WHO doesn't recommend the use of this cosmetic purpose. Okay, because in some cases, the model, especially the female model, prefer the skin tan color, right? ประเทศนะครับประเทศอยู่ที่ YouTube. Okay. Yeah. In some cases, the model doesn't want to have the pure white skin. She may prefer the tan color on her skin. So this is one of the way to get tanny skin color. Okay, it seems to be not very useful, but some people may prefer it, and they spend a lot of money for that. Let's take a look at the more useful application. Here we arrive at the application of the X-rays. Okay, above the ultraviolet. Okay, we have the band of X-ray electromagnetic wave, right? X-ray pass easily through the soft tissues like our body, but many are absorbed by the denser matter such as bone. Okay, so they use this property, and yeah, you can see that they use the effect of the X-ray on the bones. That's why they get the image of the bone in human body. Okay, you can see mainly the bone inside our body without any effect of the skin. Okay, and yeah, that's the property of the X-ray. Okay, but if you want to see everything inside your body, it's liquid, whether it's liquid, it's solid, it's blood or anything, right? We would not be able to see those stuff inside the body by using the X-ray. You have to use MRI, right? Magnetic resonance imaging technique. Okay, but in the conventional way, human has adopted the X-ray for investigating the symptom of many diseases inside human body quite a long time ago. Okay, yeah, this is the source of the X-ray, and if they want to see everything, you need to lay down on the bed, right, in the hospital. Okay, this is the photographic film which is placed behind the body. Okay, the X-ray will not penetrate some parts of our body, and that's why we get this effect. The X-ray are aimed at the film, and only the X-ray that pass through the body will expose the film. So this is the result. Another application is the gamma. Okay, gamma rays. Gamma rays has even higher energy than then the X-ray, okay, it's more dangerous than the X-ray. No one more. Oh, many people. Yes, there is projector. Okay, the device that is that will generate the camera. It will emit the camera in a certain direction. For example, here we have two more, which is the intersection point, okay, of three sources like this. It's like a projector. They have only one projector actually, but they rotate somehow, or the projector is fixed at a certain position, and they will rotate human body somehow. In any cases, okay, they just rotate so that there will be intersection point, which is known as tumor. Okay, the doctors ขออนุญาตถอดหูนะครับเสียงมันกล้องเช็คแล้วนะครับเสียงไปได้นะครับ Okay, this is the intersection point, and the doctors adopt the camera to kill cancer cells without having to do the surgery, and when the cancer cell receive the camera, okay, they will not be able to repair themselves, okay, and the healthy cells can recover themselves, so yeah, our body will return to the good condition again. This is the technique where doctors adopt or apply the gamma rays to cure the patient, which is caused by the cancer. Okay, another application is this one. Okay, we know this device. We call this device as the scintigrams. Okay, scintigram use the gamma rays as the tracer. Okay, that's the treatment process, right? But here is the investigation process. They use the gamma ray as the tracer to build up a picture of everything inside a patient. For example, you have here the sensor that detect the gamma rays. Okay, but in order to get the source or to get the gamma rays, okay, you need to inject the source of the gamma ray into patient body. Okay, you insert it by injection, and after that this liquid, okay, will go around, go everywhere in the human body, and of course this liquid has the gamma ray. Okay, the gamma ray will penetrate, okay, will go through the human skin body, okay, get out of our body, and after that you just move this sensor everywhere onto the patient body so that you can see the whole picture of the patient body. Okay, scintigram is done by putting slightly radioactive substances into a patient body, then scanning the patient to detect the gamma rays. Oh my God, we finished the first chapter. I didn't predict that we are gonna finish the first chapter. Anyway, we will continue the second chapter immediately, and then I will send you นะผมก็ไม่ได้คาดหวัง ไม่ได้คิดครับว่ามันจะจบบทที่1ได้เร็วขนาดนี้นะไม่ได้เตรียมบทที่2ไว้แต่ว่ามีรออยู่แล้วนะครับโอเคของปีที่แล้วก็ได้ Let me change somehow the date and so on นะครับขออนุญาตแก้ชื่อเรียกว่าอะไรชื่อของเทอมนิดนึงนะครับเทอมเนาะ This is the first semester right of the academic year ไม่มีอะไรเปลี่ยนมากครับ รันนิดนึงนะครับ alright and we are gonna throw it throw it to our iPad นะครับบทที่1ก็จบไปด้วยแอปพลิเคชันอย่างนี้นะครับโอเคมาแล้วto Suankularb E plus second magnetism and assessment no okay we will continue our important our second chapter plus magnetism here okay here okay let me close the zoom panel okay we today 08.06.2022 and M604 right okay oh my god yes this is the second chapter and เดี๋ยวขอฟังเสียงคุณด้วยนะเผื่อคุณพูดอะไรกันถามผมนะครับokay the title of the second chapter is magnetism and electricity and here is the semester 1 right academic year 2022 oh there are many topics in this chapter oh my god 13 okay anyway we will talk about many things in this chapter and there will be many calculation examples okay the number of calculating problems is much greater than the first chapter okay you would see mainly the explanation right you may hear only many several explanations in the first chapter but here in this chapter it is quite different there are many places we have to calculate something right okay the first topic in this chapter is magnetic field okay we need to know what is magnetic field we will calculate somehow the magnetic field strength or something like that it's if you want to find the sources of this topic you can go to the reference number 1 number 2 number 3 number 4 and we will talk about Earth's magnetic field lines okay which is very close to our life okay the place where we live here on Earth and after that we will see magnetic flux okay we will get the definition basic definition how to monitor or observe the magnetic flux in later this effect will be very close to reality in especially in engineering application magnetic field from the current carrying conductor this happen to many devices especially in electric machine the next one is magnetic force okay that will happen due to current carrying conductor okay is FILB okay we could say the next one is magnetic force okay between two conductors this is the magnetic force on current carrying conductor but this one is the force which is caused by two adjacent conductors the next one is very close to our daily life it's torque on a current loop and solenoid okay this is the idea of electric motor okay it's not okay when we talk about motor it's not the motor in the sense of the United States okay In the United States, they would say motor as the combustion engine, but here the word motor means the electric motor. Okay, we put the electricity or the current into that device, and that device will give us the torque. Okay, and here we will be able to calculate the quantity of the torque, which is caused by current loop and solenoid. And next one is the application of the torque. Okay, human developed a device, okay, to measure the current, the voltage, many quantities in electricity by using the idea of torque. Okay, and that's why this is the application of the torque. This device is known as Convenometer. Okay, you may not see Convenometer nowadays because this is the ancient generation. Okay, this is the old. Okay, the polite way to say old nets is that we have to say it's a classical era, right? So yeah, Convenometer is in the classical era. It's not widely used nowadays, okay, because once the digital technology emerged, so there are many devices that can perform better than the Convenometers, and that's why you cannot see Convenometer anymore in the real life situation. Even you work in the industry of electricity, okay, they would use the multimeter instead because it has it can give us more accuracy and it's fast. It's fast. It's easily movable to everywhere. Okay. The next one is another application of the torque. Okay, it's the direct current motor. We will investigate the direct DC. Okay, direct current is known as DC. Okay, it's the abbreviation of direct current is DC. The DC motor will be considered in this topic. The next one is the opposite functionality to the electric motor or DC motor, and that idea is called induced current and induced electromotive force. Okay, you put the torque into the electric device and you get electromotive force. Okay, if you don't understand, if it's hard to understand electromotive force, just simply know it as look at it as the voltage. Okay, the potential of two different points. Okay. The next one is Faraday's law. Okay, of the induction. This one is very close to this topic, and yes, of course, once you are able to compute the induced current, induced electromotive force, we will arrive at electric generator. Okay, which is the whole picture of this one. Okay, and we will talk about other applications of the induced EMF principle. Okay, EMF stands for electromotive force. Okay, electromotive force means this word. Yeah, EMF. Okay, simply speaking. Now let's start the first topic, which is magnetic field. Okay, magnetic field is a major quantity in physics, and there are many ways to describe the magnetic field. First of all, the magnetic field is an abstract entity that describes the influence of magnetic forces in a region. Okay, you cannot see the magnetic field by eyes. Okay, because our human eyes cannot detect that, and in nature, the magnetic field cannot be observed by eyes. It's not visible. Okay. The magnetic field is a region of space in which a magnetic force acts on or any other magnet, electric current, or moving charged particle. Okay, if you have the region and you put the current or you throw away an object that has charge, okay, you would be able to realize that there is the magnetic field in that area. The magnetic field is a field of force, actually, causing a force on material like iron when placed in the vicinity of the field. They say the magnetic field could be observed easily if you throw away a tiny piece of iron. Let's take a look at this figure. Here is the figure number 1. If you don't understand the text here, just take a look at this figure. Here is the permanent magnet bar. Okay, the small cubic shape, and it contains a permanent magnet inside. Okay, and once you have a bucket of iron pieces, tiny pieces, you just throw away into this area, and the permanent magnet will arrange all these tiny particles of iron like this. Okay, they will orient all tiny particles like this. Okay, you may ask me, what is the reason why we have to do the experiment by using the tiny pieces of iron, the fried iron actually. Any idea about that?
ครับคำถามนะครับถามว่าทำไมเราต้องใช้ผงเหล็กเล็กๆมาทำการทดลองเนี่ยมีไหมครับมีคนไหนตอบได้ไหมครับผมเสียบหูฟังอยู่นะมันไม่เหมือนห้องจริงเนาะจะได้ถามกันชัดๆนะครับห้องออนไลน์ไม่มีใครตอบนะขี้เกียจเปิดไมค์นะครับใช่ไหมก็เคยสงสัยไหมผมก็ยังสงสัยนะตอนกลับมาสอนคุณเพื่อเตรียมสอนเนี่ยทำไมต้องใช้ผงเหล็กเล็กๆอย่างนี้ด้วยครับมีใครตอบได้ไหมครับหรือว่า เงียบหายกันไปหมดแล้วครับหนีจากไปแล้วไม่มีใครตอบแล้วมีแต่พิมพ์ชื่อกันมานะครับ Okay, alright. I'll see then in this one start from okay อัครนันท์กองทัพทัศศิวราเดวิดธนกิจคันธินันท์พัชราชคริตบุรีนบัณฑิตครับคิดว่าทุกคนที่ไปฉีดวัคซีนมาครับกลับมามีสุขภาพที่แข็งแรงครับโอเคมาไม่มีปัญหาครับ Okay, what is the reason why we use the fried iron or the tiny pieces of iron or the powder of iron, you can say, because the size of the iron is very, very small. The reason behind this is that if you use a big piece of iron, okay, the strength of the magnetic field of this permanent magnet bar might not be strong enough to orient the big piece of iron. So we need to reduce the size or the mass of the iron for each particle, right? So that's why we have to use the fried version of the iron or the powder version of the iron, okay? Because each tiny particle of the iron has very, very small amounts of weight, right? Okay, that's the orientation, okay, how the permanent magnet force the iron fire, okay, the fine iron. You can see the magnetic field lines like this, okay. It's just go out of the first
the North Pole, and after that it will reach the South Pole. Okay, but you can see the line like this, right? Okay, another figure is like this. You have North Pole and South Pole. Okay, the magnetic field line will start from North Pole to South Pole. Okay, they also throw away the iron filings. Okay, a tiny piece of iron. Okay, คุณรู้จักตะไบใช่ไหมครับตะไบรู้จักไหมเหมือนกับตะไบตัดแต่งเล็บอย่างนั้นนะครับโอเคไหมแต่มันเป็นตะไบเหล็กครับคุณยังไม่เคยเจอแน่นอนมั้งยกเว้นคุณพ่อคุณแม่มีโรงงานเกี่ยวกับเครื่องกลนะครับโอเคไหมคุณก็เอาตะไบนั่นแหละไปถูกับตัวเหล็กนะครับไม่ใช่ไปถูกับแม่เหล็กนี้นะถูกับเหล็กชิ้นอื่นนะครับโอเคไหมแล้วคุณก็จะได้ผงมันทีแรกเราก็มีแท่งแม่เหล็กตั้งอยู่เฉยๆนะครับเราเทนะครับจากภาชนะที่บรรจุที่เราฝนเหล็กเป็นผงนะเทลงไปในนี้มันก็จะจัดเรียงแบบนี้นะครับโอเคไหมHere's the North Pole and the magnetic field line will start from the North Pole to the South Pole. Okay, you can see the line here. This is called magnetic field lines. Okay, yeah. In that generation, many scientists, many physicists try to observe what's going on about electricity or magnetic field, something like that. Okay, another shape of the permanent magnet is that like this. Okay, this is the typical version, right? It's the bar or small qubit version. Okay, this one is, what is that? If you have been close to the horse, okay, we're gonna need the shoe for the horse, right? So that the horse will not get hurt once he or she going somewhere in a bad situation on the road. So human will adopt this metal onto the feet of the horses. Okay, and that's why we call horseshoe magnet. Okay, this one is like a shoe for the horses. ภาษาไทยก็จะเรียกว่าแม่เหล็กเกือกม้าป่ะครับโอเคไหมเกือกม้าแต่ไม่ได้เอาเกือกม้ามาทำครับมันก็เป็นแม่เหล็กนี่แหละครับแต่ว่าเชฟรูปร่างมันคล้ายๆเกือกม้าอย่างเงี้ยเกือกม้าก็คือรองเท้าม้าที่เขาแปลมาตรงๆเนี่ย horseshoe เนี่ยครับโอเคไหมโอเคhorseshoe เนี่ยครับโอเคไหมOkay, if you throw away, okay, of course, we need to know there will be two poles like this, North Pole and South Pole. I don't know which one. If you throw away again the iron fillings, okay, a tiny piece of iron, okay, they will arrange like this. Okay, this might be a North Pole, and in here will be South Pole, and the magnetic field line will start from the North Pole to the South Pole. Okay. Let's move to the next explanation. I don't know what time should we finish. Let me check the time. Otherwise, you will complain me when I last the lecture too long. Suankularb in this semester, right? Semester 1. ผมก็จำไม่ได้สักทีครับรู้แต่ว่าเปิดเซฟไว้อยู่ครับโอเคwe need to finish for the 14 right 14 20 or 14 something like that. Okay, 14 we still have 45 minutes. Okay, magnetic field is a picture that we use as the tool to describe how magnetic field is distributed in the space around something magnetic. Okay, here is the permanent magnet. We just throw away the iron fillings, and you can see that there are many magnetic field lines. Okay. First, we know the quantity of the magnetic field. Okay, through the magnetic field lines, because once there is a spatial arrangement of the lines, and that's the place where we can realize that there is the magnetic field in this area. Okay, magnetic field is a vector quantity. It is a vector field that describes the magnetic influence of electric charges or magnetized materials. Okay. The purpose of building up, the purpose for human to build up the magnetic field is that they wanna know how much force we could get in this environment. Magnetic field lines is the next quantity. Okay, is the visible effect that you can see. Maybe I will ask for the permanent magnet like this and ask for the iron filling so that you can play with them during the laboratory period, right? Maybe in the next week, because we're gonna meet we're gonna see each other on next week, right? Apart from the polarization experiments, okay, because we have 2 periods, right? We should have more experiment to do. Okay. Magnetic field lines are the trajectories. Okay, it's a line. It's curved line. It's not a straight line. It's the trajectory that the not magnetic monopole would follow when placed in the magnetic field. Okay. Yeah, there will be magnetic field line in that environment, in that region. If you don't completely understand, it's no problem. Here is the better picture. Those lines here, okay, might not be very smooth, but human can describe it easily by drawing a smooth curve like this. Okay, the magnetic field line start from North Pole. Okay, this the red one here with the letter N represents the North Pole, and on the left we have the letter S that represents the South Pole. Okay, if you don't believe the blue lines here, these 3 blue lines, just leave the compass. You know compass, right? ภาษาไทยก็เรียกว่าเข็มทิศเนาะคุณน่าจะทราบดีกว่าผมคุณเรียนหลักสูตรภาษาอังกฤษครับ Okay, there is, if you have the compass, you just leave it in this area, and there will be the arrow, right? Arrow of the compass. The end of the arrow will represent the destination at that location. For example, you leave the compass here. The arrow is pointing in this way. If you go here, the compass of the arrow of the compass will point in this direction, and here in this location, the end of the arrow will point in this way. Okay, and that's why human simply conclude that there is magnetic field lines, and the direction is not straight. Okay, it's a curve around, or it's the curve between south and north poles. Okay, the compass is useful to find the location direction of the magnetic field. Okay, magnetic field has the following properties. The first one, magnetic field lines never cross. Okay, it means this line will never get intersection to this one, and this one will never get the intersection to this one, and that's the meaning of the first property. Magnetic field line never cross. The density of field lines indicates the strength of the field. Okay, if you can count the magnetic field lines per certain area, the place that has more number of the field lines, magnetic field lines, will have strong magnetic field. Okay, it's known as more dense than the one before. Okay, the magnetic field lines are continuous. Okay, you cannot say magnetic field line, you cut some part of the lines here. No, it's not true. Okay, It's not under the assumption of the physicists. Or maybe in other universe you can do that. But this one, the magnetic field lines are continuous. Okay, they will follow continuously in this way and follow the lower line like this everywhere, every time. The magnetic field sources are essentially dipolar in nature. So if you cut a piece of permanent magnet, there will be north pole and south pole in general. It is very hard that you cut the permanent magnet and you get only the north pole. No, it's not very easy to find that, and that's why they say magnetic field line is dipolar. Di means two, right? With two directions. The direction of the field is required. So once you draw the line, you need also to leave the arrow to represent the direction of the destination of that magnetic field line. The strength of the field, the magnetic field lines can be visualized quite easily in the real world by dropping the fillings around something like this. You have already seen, you can get in touch with how humans discover the magnetic field lines once they throw away the iron fillings in the area of permanent magnet. Okay, the next one is the strength of the field is proportional to the closeness of the lines. Okay, if you are close to the letter N, you get very strong magnetic field, and if you are quite far from the north pole or the south pole, you get weaker strength of the field. Magnetic field lines follow the superposition principle. It means take a look at this. Okay, we are talking about the superposition principle. Okay, if you say something about a superposition, okay, the superposition exists in many applications. For example, in engineering, there will be also the rule of superposition for many subjects. Okay, we will try to understand the idea of the superposition. Here you have two permanent magnets, two permanent magnet bars. You have the north pole, you have the south pole, you have north pole and south pole here. Okay, each bar has north and south, and of course in the first, on the left bar, the magnetic field line will start from the north pole like this, with this curve and this curve, right? They can even go out in this direction for other purposes. Okay, and at the south pole, the first or the left magnetic bar, the field lines will go to letter S. Okay, the field lines will reach letter S everywhere. All right, and even the field lines from somewhere else, they will go to the letter S. In the same way, the magnetic bar on the right, okay, there it will emit the magnetic field lines like this. Okay, like this, and even this one. They emit even the magnetic field line in this direction, and of course, the south pole is the location where we absorb the magnetic field, the destination of the magnetic field line, right? Here, many field lines from the north pole of this bar, magnetic bar, will go to this area, okay, which is denoted by the south pole by human. Okay, once you move it to be closer to each other, of course, this one will only receive the magnetic field, right? And this one will only emit the field lines. And if you let them be closer to each other, this line, the green one, and these lines, the violet one, will combine. Okay, will combine themselves smoothly, and the combination is known as superposition. Okay, if you combine something that means it's the superposition theorem or superposition law principle. Sorry. Okay, these random files or force or magnetic field lines will be smooth like this. Okay, and this one still remain the same. This one still remain the same. Here's the field lines for two adjacent dipoles. Will be more horizontal. Okay, they will combine them together. Okay, now we will get into the mathematical formula of the magnetic field. In electromagnetics, the term magnetic field is used for two things, but both are very close to each other. Okay, when we say magnetic field, there can be two meanings. Okay, the first one is the letter H with the arrow on top of that. The second one is the letter B with also the arrow on top of that. Okay, well, the magnetic field strength will be measured in this is the magnetic field strength. Okay, the letter H is measured in ampere per meter. But for us, if you don't go to any special book, you may not have any chance to know this variable H. Okay, but during my generation, I also have a chance to deal with the letter H. Okay, but for us here in the high school level, we are gonna consider mainly the letter B, and the letter B is denoted by magnetic flux density. Okay, we will talk about how to calculate the magnetic flux density later. And let's talk about the units. This one is the current per meter. So per length, right? Current per length. So it's ampere per meter. And the unit of the magnetic flux density is known already to you, right? I have talked about magnetic field. Magnetic flux density several times. The unit of the magnetic flux density is denoted by this simple letter T. It's Tesla. Okay, Tesla is the surname of a Serbian engineer, electrical engineer. Okay, the SI version of Tesla is known as is equal to, not known as, it's kilogram per second square and per ampere. And on Earth, the Earth magnetic field at the surface level, right, is about 5 times 10 to 5 Tesla. Okay, which is very, very, very weak, right? It's not strong. Okay, it's quite weak. Because it has the scaling factor 10 to negative 5. Okay, almost one by 1 million. Okay, we will. Oh, it's not good at all to study this thing in online manner, because I cannot show you how to use your right hand to determine the direction of the force in this problem, in this scenario. Okay, let's forget the letter H. Okay, the magnetic field strength. We will consider only magnetic flux density, the letter B. And here is the magnetic field lines, okay, from left to right. The magnetic field line start from any source and is just image the magnetic field line like this. Magnetic field lines, magnetic field lines, magnetic field lines. And if we have the two types of particle, the first one is the charged one. For example, it's helium-42, the nucleus of helium-42. If you can pick up the helium-42 by your hand and you throw it upward, all right, you throw the, for example, helium-42 nucleus upward like this, it's not going, this particle will not go directly upward. Okay, there will be a slight deviation. And let's talk about the that's the effect of the positive charge, right? Yeah, in real world, there is also another type of the charge. It's known as negative charge, right? For example, the candidate for negative charge is electron. Okay, that's one of the example. We have helium 42, we have electron, and that we have to use the right hand rule. Okay, ผมจะทำไงดีมันออนไลน์ครับโอเคมาOkay, you have this vector pointing up. That's the velocity vector or speed, and here is the vector B. And if you curl your finger like this, your forefinger, the force will be in this direction. And here is the vector of force. Okay, from สำหรับใครที่อยู่ที่Streamlab นะครับมันถ่ายเห็นมือได้นะผมจะหมุนมือให้ดูนะครับhere is the vector v, right? V velocity vector or speed vector, and you curl your four fingers to the vector b, right? And your thumb direction will represent the force direction like this. สำหรับคนที่อยู่ที่ซูมผมดูกล้องอย่างนี้นะมองเห็นหรือเปล่าครับกล้องนะครับ you curl your four fingers from vector v to vector b and you get the direction of the vector f. Okay, and okay, let's simply go into the detail. F is q. Okay, q is the amount of charge. Okay, whether it's once this one is positive charge, this one will be positive value. Once your charge is negative, right? Once your charge has negative amount of charge, you would be this one will be negative. Okay, it's going to be positive if your particle is positive. It will be negative if your particle has a negative charge. And the next one is that this is the actual formula. It's V cross B, right? You know the cross product, right? ทุกคนทราบ cross product ใช่ไหมครับรู้จักไหมเอ่ยถ้าไม่รู้จักผมจะเปิดหน้าแล้วยกตัวอย่างให้ดูนะครับเป็นสอนแมทไปพังๆให้คุณได้รู้จักคำว่า cross product ทุกคนทราบไหมครับหรือว่าเรียนพิเศษพบมาแล้วหรือว่ามออื่นก็พบ cross product มาแล้วผมก็จะได้ไม่อธิบายครับเอาอย่างไรดีครับอันนี้ไม่ยากใช่ไหมเป็นใช่ทุกคนใช่ไหมครับผมไม่ต้องอธิบายเนาะว่า cross หรือว่าไม่เป็นไม่รู้โอเคผมจะได้เปิดหน้าบอกให้นะครับโอเคcross product is somehow like this. Intro ไปเลยให้รู้จักไปเลยนะครับปูพื้นถึงปริญญาตรีนะครับปริญญาตรีก็ต้องใช้แน่นอนครับจนเรียนวิชาแมทของปริญญาตรีนะโอเคcross product. Before we talk about cross product, we need to introduce you to dot product. ก่อนที่จะพูดถึง cross product ไป dot product ก่อนครับโอเคมาแม่อาจารย์ชอบออกนอกลูกนอกทางไม่ใช่ครับคือมันมาสเต็ปง่ายไปหายากครับ cross product มันยากแล้ว Okay, before we talk about cross product, we have to say something about dot product. Okay, of course, here is the chance for us to investigate the algebraic manipulation of the vector quantities, right? Let's talk about vector. Okay, if you have vector A, it could be 1i. I is unit vector along the x-axis minus 2j unit vector along y-axis and plus 3j k unit vector along z axis. Okay, let me denote it for you. Unit vector along the x axis. J, you know, right? It's unit. Unit vector along y axis, and unit vector k, it's also a unit vector along z axis. Okay, let me draw it for you. If you have the z axis like this, if you have the x axis like this, and if you have the y axis like that, unit vector I means this vector, and the length here is 1. Okay, unit vector j is this one. This is the unit vector j. The length here is also 1. Okay, and what about unit vector k? Unit vector k is this one. Okay, also, and the length here is also number 1. Okay, you understand everything, right? Unit vector I to k. Okay, the unit vector means the vector that has unit of 1. Okay, this one is the vector that has its length as 1 or unity. Okay, and this is called unit vector. Okay, it can be oriented in different basic 3 directions, right? This is the x-axis, this is the y-axis, that's the z-axis. All right. Yes, of course. For us, I minus 2j and 3k, where is that? We go along the x-axis by 1, okay, this location. We go along the y-axis by minus 2. We go to this. And we go along the z-axis by 3, so we go up like this. And here is the destination. And the vector A will be this one. Okay, this is known as vector A. Okay. Again,พูดอีกรอบนะ you go along the x-axis by 1 according to this one. You go along the y-axis by minus 2. So if you go in this way, it's plus 2. You have to go in this way, minus 2. And after that, you go to the z-axis by 3. So it's going to be a little bit longer. So and the destination here will be the destination of the vector in this one. All right. Let's talk about the dot product. If you have vector A like that, if we have another vector, which is vector B, let's say 3i minus 6j unit vector along the z-axis, unit vector along the x-axis, and if we have here minus 15k, the dot product between vector A and vector B will be, okay, this one, 1i minus 2j plus 3k dot 3i minus 15k. Okay, how could we calculate it? It's only the summation between the first. You know that the coefficient in front of this one is number 1, right? You just write down number 1. and times the coefficient of unit vector I of the second component, which is vector b here, is 3, right? And then you say plus the product between those two j components, those y components, minus 2 and minus 6, okay, minus 2 and minus 6. And the third component is number 3, and here is minus 15, 3 and minus 15, right? You have here the product of the first pair, right? Which is 1 and 3. It's going to be number 3, and the product of the second pair is 12, right? Minus and minus will be positive, right? You know this. And so it's going to be plus and 12 in here the result of the product between 3 and 15 is going to be minus 45. So let's combine these. 15 and minus 45 is going to remain negative 30. Okay, and that's the dot product. Okay, all right, you understand how to compute the dot product. Dot product use the notation ทำไมเมาส์ผมไม่ไป okay here the dot product use the dot notation here between two vectors. Let's talk about the cross product. dot product เป็นนะครับทุกคนเป็นเนาะทำให้ดู1ตัวอย่างหรือว่ายังไม่พอต้องการอีก1ตัวอย่างอาจารย์ทำให้ดูอีก1ตัวอย่างนะครับจะได้เคลียร์หรือว่ายังไงนะครับบอกได้นะครับถ้าไม่มีใครเปิดไมค์ผมก็ไป cross product นะlet's talk about cross product. What is the result of A cross B? Okay, in vector calculation you can have the summation of two vectors, right? A plus B. I think you know how to do that, right? A plus B. It's I minus 2j minus plus 3k and plus, right? A second component, second vector is 3i minus 6j minus 15k. Of course, it's going to be 1 plus 3 for the component I, and plus minus 2 minus 6 for the second component k, and plus the third component 3 minus 15k. And of course, you just compute this one, right? 1 and 4 minus 2 and minus 6, 3 and minus 15 is going to be 4i minus 8j and negative 12k. All right, you know the vector addition, right? That's how the vector can be added together. The answer is different, totally different from the dot product. Dot product will give you only the number without any vector. Okay, but the summation of two vectors will return the vector quantity to you. Okay, and in the same way, do you want any example about vector subtraction? Vector A minus vector B, something like that. Do you want the example about that? If yes, I'm going to solve A minus B for you. But if you think it's quite simple, I will skip that. Okay. ต้องการให้ทำ A ลบ B ให้ดูไหมครับอันนี้เปิดพื้นฐานของเวกเตอร์นะ You know that there are many way of algebraic manipulation, algebraic calculation for the vector. Right? The cross product in multiplication for two vectors, there are two types of multiplication of two vectors. The first one is called dot product. The second one is called cross product. Cross product is a little bit more complicated than dot product. Okay, let's consider คนรู้จัก determinant ใช่ไหมครับ ห า determinant ของ metric เป็นใช่ไหมหาเป็นนะครับโอเคไหมถ้าไม่เป็นบอกนะครับโอเคไหมไม่งั้นผมก็ไปนะครับโอเคand the first row of this matrix we're gonna say unit vector I. The second component in the first row is unit vector J. The third component of this row is unit vector K. Okay, I, J, K, and A is the first vector, right? It will be filled here in the second row. A is I minus 2 minus I minus 2 and plus 3, right? So we say here number 1, number 2, and number 3. That's the coefficient of the vector A. Let's talk about vector B. Vector B is this one, right? 3i minus 6j plus 15k minus 15k. So we would have 3 and then minus 6 and minus 15 like this. Okay, and each time นะเป็นนะครับวางเป็นนะ The first row, in the first row we lay down the 3 unit vectors, unit vector I, unit vector J, unit vector K. That's the first row of this 3 by 3 matrix. And in the second row we will lay down the coefficient of the first vector. First vector is vector A, which is number 1. We write number 1 here. Negative 2 we write down here, negative 2. Plus 3 we write down number 3 here. And in the last row, you know, right, this is the row and here is the column, right, of the matrices. Okay, in the third row we will write down the coefficient of the vector B, which is 3. We write down 3. Negative 6 we write down minus 6. Okay, and negative 15 we write down minus 15. Okay, now it's time for us to compute this determinant, right? Yes, of course. In this way you have I minus 2 minus 15, right? So you have 30 unit vector I. And this one J3 and 3 you get plus 9J. Okay, and this component K will touch number 1 and minus 6, so we get minus 6J. Okay, and in the in another direction for the determinant computation, we have to go along this way, right? Go upright, not only go down, right? If we go upright, it's going to be minus 6k. Minus 6k. And here minus, oh no, sorry. If you go upright, you have to lay down negative value, minus of anything. Okay, but once you investigate it, you have 3 and minus 2 is 6k, right? Okay, 6k. And this one minus 6 and 3 and I, you get minus 18i, right? Minus 18i minus 18 and I. You can observe that we didn't start from I, okay? We start from K and after that I. And in the last, going up right direction, minus 15, 1 and J, right? We write down negative because we go upright. Minus 15 and number 1, right? Minus 15J. 15 and J, right? Okay, let's combine that. This is 30I minus 18I, so it's 12I. J, what about J? Minus 6 and oh, this is minus, my God, 18 minus 2 and 6. Wait, okay, 12I, no, not 12I, it's 48I. And then J is plus 15. 15 and minus 6, right? 15, 6, plus 9. Plus 9J. And K we have 6 and plus K-I-J. Why we have, oh no, 9, 6, oh this one, this K, sorry for that. K, okay, and yeah, we have minus 6 and plus 6K, so we get 0. Even if we don't have to write 0 at all, 48. Oh, 48I. And plus 9J without K. Because the component along the z-axis K is 0. We don't have to write K at all. Okay, this is the cross product. You get the idea about that, right? The cross product. Okay, that's a sense in mathematics. For us here, first before we get we make the computation to get the quantity, you need to be able to find the direction. Okay, by using the right hand rule again. Right hand rule. You start to lay your 4 fingers to the vector V and rotate it to the vector B. Your thumb direction will point this way, and that's the induced force from the scenario due to the motion of the charge in the area of magnetic field. Okay, and the length of it could be found like this. F is QVB, QV cross B, and in the scalar form QVB psi theta, which is the angle between V and B. All right, and that's QVB psi theta. For the negative charge, okay, the direction of the force will be in the opposite way like this. Okay, not going like this, in the opposite way. Once we have the charged particle, and if we throw it with a speed, okay, if the charged particle is moving like this, let's say this is the helium-42 nucleus of helium-42. Someone had accelerated this particle, and the particle move with a constant speed like this. And if there is magnetic field in the green color, right? Sorry, it's too small. Okay. If you have the magnetic field that points in this way, you have to rotate your 4 finger from this one, right? นี่นะครับสำหรับคนที่อยู่ที่ Streamlab นะผมหมุนมือให้ดูกล้องครับอย่างนี้นะปึ๊บ okay, and your thumb direction is going to point upward like this. From V to B, you rotate your 4 finger in this way, okay, and after that your thumb direction will point in this direction, which is the upward point. Yeah, we get the induced direction. Okay, the magnetic force is perpendicular to both V and B. And yes, of course, the formula, as I mentioned before, the force is often known as Lorentz force, okay, which can be determined by F is Q V cross B okay F is Q V cross B กับใครยังไม่ได้พิมพ์ชื่อนะครับยังไม่ได้เช็คชื่อก็พิมพ์มานะครับเพราะว่าเดี๋ยวจะได้ใช้สิทธิ์ครับใครลาก็ส่งจดหมายลานะครับ F is equal to Q V cross B as I told you V is the cross product I have already explained you what is the cross product right here okay เดี๋ยวผมเสียวๆผมขอเช็คให้คุณดีกว่านะเดี๋ยวสอนคุณไปผิดๆกับ cross product เดี๋ยวผมเช็คคือผลคูณนะไม่ได้เช็คว่าทฤษฎีผิดอะไรนะเช็คคือผลคูณว่าผมใส่ถูกต้องไหมนะครับโอเคA is what is that 1 minus 2 and 3 right B is 3 minus 6 right 3 minus 6 and minus 15 right and we want to find A cross B and that's cross A comma B see what's going on cross oh my god stupid only 2 S okay double S 2 S's okay here we have นั่นไงผมว่าแล้วผมพาคุณผิด one oh no 15 not minus 1 this is 15 okay it's the นั่นไงผิดจริงๆด้วยนะครับ 1 minus 2 and 3 minus 6 and 15 we get the outcome as 48 and 24 but it's not case here what is that 30i right plus 30i 9j right positive negative 6k negative 6k all right going up minus 6k and I minus 6 and 3 minus 18 and here we have minus j right j for the j component we have 15 and 9 oh my god yeah it should be 24 yeah ผมแล้วว่าแล้วครับช่างงนครับว่าจะพาคุณผิด okay this is 24 plus 24 okay that's the cross product okay I try to check with the calculator so that there will be no error at all okay 48เขาบอกว่าเป็น 1420 นะครับผมต้องปล่อยคุณยังไงเนี่ย 1400 เนาะไม่ได้อู้นะคือเขาต้องให้คุณเบรกตอนออนไลน์คาบละ10 นาทีใช่ไหมก็ไม่ได้เบรกเลยก็จะเบรก20ตรงนี้เลยนะครับโอเคsee you on Friday morning right we need to quit the section for M604 right now we arrive at here today is 08.06.20 22 see you on Friday บ๊ายบายครับสวัสดีครับ This is better. Okay, good afternoon, everyone. Welcome you to SCI33205. This is the session for M605, right? So, we arrive at the microwave region application, right? We still talk about the application of the electromagnetic wave, and yes, of course, this person, Percy Spencer, was the inventor of the microwave oven on Earth. Okay, he worked as the radar engineer, and he discovered this effect accidentally, okay, without determination. ของ605ได้เขียน605ไว้ไหมครับเวลาพิมพ์ชื่อมาหรือว่าพิมพ์กันมาเลยคนแรกช่วยพิมพ์605หน่อยนะครับไม่งั้นเดี๋ยวผมงงครับ Okay, you can even go to the YouTube channel like this, okay, and just type your name here somewhere. This is ประเทศ in M604, or you go to any channel like Zoom copy version, okay, and another version is this one. You can see me also from this live stream. Okay, there are 4 channels in YouTube. Just use the keyword SCI33205. That's the code of our subject, right? Okay, yes, we let the electromagnetic wave, okay, in the microwave region to get out of this one. It's known as resonant cavity magnetron, and here's the waveguide. Okay, that's the pipe, okay, that control the direction flow of this electromagnetic wave. And once the microwave hit the substance, okay, the substance will collect the heat from electromagnetic wave. Once you let it propagate longer and the heat is sufficient, the solid form of this product will be melted down. Okay, and another application of the electromagnetic wave is the wireless communication. We have the cellular configuration like this, right? This is the hexagonal cell. Okay, we have a flat area on Earth, and we have the handy, right, or the mobile phone of the users, and this is the tower. This tower is known as the base station. Okay, base station, and the base station will transmit the electromagnetic wave to the to the handy or mobile phone. One cell can have many base stations, but at the center of the cell will be the major one. Okay, it will talk with this mobile phone and this mobile phone. In every cell, you have mobile device, and the base station will talk or communicate with the mobile device like this, mobile or handy. If you move from this cell to this cell, okay, the whole system will switch the connection from this base station to this base station immediately or automatically. Okay, so that you get a good quality of connection to the system. Okay. Nowadays we arrive at the 5G of so we have many we have more bandwidth to transmit data like high quality videos and so on. Okay, let's move to the next infrared or electromagnetic wave in infrared region, and there will be receiver at the television. The receiver will receive the information from the remote control, and it's gonna change the television channel, or it's gonna increase the the sound of the speaker in the television for any functionality. Okay, infrared is also used to burn the skin of human, and infrared comes from the sun. It is said here that we cannot see the infrared radiation, but we can feel it as warmth coming from the sun. It means the infrared is out of the visible region of our human eyes, right? So we cannot see the infrared by eyes. What we can see is only the light in several colors, in yellow, in blue, in green, in red, in many regions, but we cannot see the infrared. Okay, but if you stay like on the beach and in the sunshine for a long time, okay, your skin will get burned, and that's the effect from the infrared. But we cannot see the infrared. Okay, what we can feel is only the warmth or the heat coming from the sun. Another application is the use of infrared in investigation of passenger, especially at the airport terminal. Here is the infrared camera. Where once the passenger gets out of the airplane, okay, they need to go to the airport gate and so on. A basic step to detect whether the passenger has a special symptom, for example, at the border of the country. Nowadays, people would travel mainly by airplane, right? And they use the infrared camera to detect whether the passenger has any fever or not, and they use the temperature, right, as the main source of identification. For example, the temperature, which is very close to 37, about 36.5, yeah, we will see the skin of that passenger in the red here, and it's dangerous, it's hot spot because the temperature is high here. In any other part of the body, everything is fine, but it seems that this person is under fever period. So because his temperature is high, that's the first way. That's the way many airports they use to detect the passenger due to the infection of several pandemic. Okay. Passenger arriving or leaving countries can be checked by simple fevers such as colds or influenza, something more serious by thermal imaging. Another application is the infrared thermography for the night time. Okay, this is the result from the security camera. It is used to take the picture at night. Okay, everything is dark here, but this camera is set up for taking or capturing the human that has heat. Okay, of course, especially in the cold weather country, the tree here is cold, right? Outside the building, everything is cold, but human would have heat inside the body, right? And when it because in manyดร.มีลิงก์ซูม3160100606ครับ the แป๊บนึงนะครับ where is that? And นะครับผมส่งลิงก์ oh no not this one, it's not the link here. It's M605, right? This one. This one, right? 605. And where is that? This one, right? Okay. Wait, my God. The body, right? So this camera can differentiate the object that has heat and the object that is in cold condition, and that's why they can mention the body of these strange people. I would say that in many countries, because they have no problem about social welfare, and each house may not have the wall, okay, to protect themselves from strange people, because everyone is in a good social welfare. But it is possible that strange people who wants to do something bad to the other may come to the building or the entrance of any house during nighttime for the strange purpose, and yeah, they may come during nighttime like this, and we can do the security by installing the IR camera, okay, to observe the strange people like this. Okay, if once you can see the strange people like this, and you can call the police, all right, to help you from this situation. I don't understand why I could not. All right. Oh, okay. Own or ancient technology already. You can observe that the camera in your mobile phone or in modern digital camera works very well during night time. So in low light scenarios, we may not need the infrared camera at all, because nowadays the camera in your mobile phone can discover everything during night time, okay, because the technology go. Another application of the electromagnetic wave is in the ultraviolet region. You have planted many fruits or anything, right? You grow up many plants, and you get a product in terms of fruits or other agricultural products. And of course, once the product is too much in some countries, they want to export their products in terms of fruits to other countries, because the fruit may go by ships, or it may take several days or months, and if you don't take care of them from the ground, from the farm, there will be some bacteria or some fungi, and if you let them stay on the skin of the fruits for quite long time, the fungi or the bacteria may destroy the skin or the whole piece of your product of your fruit. Okay, that's not what we want, right? So human is clever. They try to reduce the amount of unwanted living creatures, which is bacteria or fungi. Okay, they just project the UV light onto the fruits like this, so that the bacteria will be cured and fungi will be removed. All right, now the skin of this fruit is clean, and after that they can wrap it with plastic and so on. Okay, once they cover with special soft plastic, then it's time to deliver this product to other country for a long time. 1 week, 2 weeks, there will be no big effect, deteriorating effect to this product, agricultural products. All right. Another application of the electromagnetic wave is to use to detect whether that banknote is the genuine one or not. Okay, you know that in our life, money is important. Money is the matter to share. Okay, to get some services, to get the product for anything as you want in your life. And the bad people may create the banknotes in artificial way, okay, and that's the fake banknote. And the banknote that is created by the government should have a very complicated layer of one banknote. They laid out even a special bar, and this bar is made of special chemical agent. It will return the light to us, to our human eyes. When this bar absorb the ultraviolet light, okay, the UV light. Okay, but the UV light is not observable to human eyes, right? It's beyond the scope of our human eye ability. So, the government just laid out this bar. But if you look at every day, you cannot see this bar. You can see this bar if there is UV light that hits this banknote, okay, and this bar will emit the special thing to our human eyes. They can even lay down a number 20, like the price, the price of these banknotes. Here it's 20. Okay, they can use this chemical agent in any alphabet. Okay, and the fake banknote may not have this bar, and we use this difference to detect whether that banknote is fake or real, okay, or genuine one. Yeah, this is the UV light source. Okay, it might be useful for you if you are the owner of a shop or the cashier of any department store may have this device, okay, to detect whether your banknote is correct or not, or is genuine or not, right? Another one is that we are here in Thailand, and we have many chances, right? Many chances to get sunshine. It's no problem to us. Many Thai may even try to escape from the sunshine, okay, by protecting themselves with jacket, by lotion, okay, and many things, right? But for the people who live in cold area, like in the European continent, in United States, in Canada, for example, they are very cold. And for the people in Finland, in Sweden, in Norway, they or in Russia also they have very less chance to get the sunshine, and yeah, they need some days they want to get the sunshine. Okay, they may go to the shop. Okay, I don't know in other countries because I have never seen it, but in Germany they have the so-called sunbad. Okay, sunbad, SUNBAD. It means the place that you can get sunshine. But in Germany, you may have the chance to get sunshine only 1 month, okay, without wearing the jacket, and 10 days you can get the weather as same as here in Thailand. Okay, they have very little chance in a year, so the shop may offer the artificial ultraviolet light or artificial light, and the people may get into that shop and pay the money, okay, pay for the service, and just lay down onto the bed, and they turn on or switch on the lamp, and this lamp will create the UV lights, okay, in the same way as the sun. But this sunshine is controllable. Okay, this sunshine can be controlled by the owner of this shop, whether you want how much intensity you want for laying down this. Okay, and you can control the time to take this sunshine. Okay, other people who don't want to get the natural sunshine, okay, because natural sunshine might be not uniform, and the natural sunshine may cause sunburn at times. Okay, I have lived in Germany, and the owner of the building that I pay for the rental of an apartment would go often to the beach in Spain, okay, because Spain is under นะครับวิสพลนะครับชื่อมานะครับไม่ได้นะครับที่ YouTube ก็ได้นะครับไม่ต้องที่ซูมก็ได้นะครับถ้าบางทีผมไม่ได้มองเห็นที่ซูมนะครับบางทีถ้าปิดหน้าซูมไปมันก็จะมองไม่เห็นแล้วก็จะไม่ได้กดรับคุณครับคุณก็เข้าไปเช็คที่ YouTube ก็ได้นะครับเอาช่องไหนก็ได้ครับตามที่คุณอยากดูนะครับโอเคyeah the owner of the building that I paid for the room apartment rental in Germany would go often to the beach in Spain because Spain is lower, okay, it's warmer, has warmer weather than Germany. In Germany they are cold, okay, almost all year, and she would return to Germany with a small black dot on her skin, okay, and yeah, because the people would call for sunshine, but for us here in Thailand we don't want that, right? We try to protect by using the UV sunblock cream even, right? Okay, yeah, that's different for different location. Okay, physicians may use tanning devices to treat the skin conditions such as psoriasis. Okay, I don't know psoriasis in Thai. ใครทราบไหมครับ psoriasis แปลว่าโรคอะไรโรคที่เกี่ยวกับขาดแสงป่ะนะครับประมาณนั้น but the WHO doesn't recommend the use of UV light for cosmetic purpose. You know, it's not necessary, but for the people in North America, in European continent, or in even Russia, they would feel that they are in a good level in the society if their skin look tan, okay, seems to be tan, not pure white or smoothly white, okay, and that's why they try to differentiate them from other classes in the society by going to the sunshine artificial sunshine shop like this. But WHO doesn't recommend to use this one for cosmetic purpose, for decoration, because it has some effect to your health also. Okay, the next application of electromagnetic wave is due to the X-ray. We use X-ray to investigate the bone in our human body, right? X-ray can pass easily the soft tissue of our body, but it will be absorbed by our denser matter, for example, the bone. So yes, the X-ray will be projected to our human body, and any part that is absorbed, okay, will appear here as the white area. Okay, what is the purpose for it? Okay, for example, if you get back pain, you are painful at your back, and they want to, the doctor wants to investigate whether is there any strengthening that happens to your backbone or not. Okay, the doctor may ask you to take the X-ray, and once the doctor gets the result from the X-ray unit in a hospital, he can observe, for example, the backbone of this person is not straight. Okay, it's bent a little bit, so there is something strange, and the doctor can make a correct decision to treat your body so that the patient will not be painful anymore. Okay, X-ray serve as a good medium to help the doctor to cure the patient. Okay, this photographic film is placed behind the body. Okay, you lay it down here, and there will be photographic film. And yes, of course, the X-ray are aimed at the film. Only the X-ray that pass through the body will expose the film. Okay, and that's why we can see somehow the whole body. But X-ray is the way to see the bone of human body, right? If you want to see everything, like stomach in any part, like liver, heart, and so on, you cannot use X-ray, because X-ray cannot tell you what is going on with those elements in your body. You need to use the magnetic resonance imaging, right? The MRI. MRI can tell you everything, even in the liquid phase, like brain, heart, liver, and other components inside your body. Okay, you have to go to MRI, not X-ray. X-ray will tell you something about the bone at a certain point you want to investigate. Okay, another application of the electromagnetic wave is gamma ray. Gamma rays can be used to treat the cancer problem in human body. For example, the doctor knows from the science that the cancer cell cannot recover itself if someone destroy it. Okay, so once the doctor knows this principle, he may want to help the patient to remove the cancer cell from the patient body by using the gamma ray projector. Okay, for example, here is the place that the doctor can rotate this projector, and once he rotates, there will be the intersection of every time, and this location might be the location of the cancer cell, and it's called tumor. Okay, this is the intersection point of different angles of projection, and the heat will appear here because this is the point that collects the gamma ray in every direction. So if this is the cancer area, the cancer cell will be destroyed, will die, and it cannot recover again. Okay, even we we transmit the gamma ray to the good cell, not the cancer cell. The good cell, okay, may get some problem with that, okay, but it will recover itself to become a good condition again, and that's the way the doctor used gamma ray to cure the patient for the cancer. Another application of the gamma ray is the tracer idea. In this way, the doctor arrives at the investigation process. It's not the treatment process. Okay, this patient came with special symptom, and the doctor would ask for the symptoms, and he may guess that there might be something wrong inside this body, and they use the gamma ray to detect. Okay, the technique in this manner is that they have to inject the liquid that has gamma ray, that can emit gamma ray. Okay, it's a radioactive liquid. We insert this one into the blood vessel in this arm of the patient. Okay, the blood will carry out and go out everywhere until the leg of this patient body, and after that, once the liquid stay well on the blood vessel, this liquid, okay, will emit the gamma rays. Okay, we cannot see the gamma ray by eyes. The way is that we have to use the device, okay, to count the number of gamma rays. Okay, how strong is the gamma ray emits, right? They can move this one everywhere. If there's something wrong, okay, we will be informed by this image, okay, medical image. All right, this device is known as scintigram. Okay, scintigram is done by putting slightly radioactive substances into a patient body, that's scanning the patient to detect the gamma rays. Okay, yeah, this is the application of the electromagnetic wave, and we finished the first chapter. Let's start the second chapter. I didn't send you yet the second chapter. ครับมีคำถามนะครับเกี่ยวกับการประยุกต์ใช้เครื่องเหล็กไฟฟ้านะครับก็โปรดบอกนะครับโอเค if not then let me close this the panel of Zoom so that we have 100% area for direction. Okay, we arrive at the second chapter. The title of the second chapter is magnetism and electricity. Okay, something about magnetic effects and electricity. The content in this chapter is the following. We will consider the magnetic field. We will ผมจบที่ 1600 ใช่ไหมครับก็ต้อง1540 เนาะใช่ไหม1540 ครับต้องปล่อยคุณนะเพราะเบรก20 นาทีนะครับโอเค magnetic field is the first quantity we will consider. Okay, and we will see some properties of the magnetic field. If you don't understand, you can go to reference number 1, 2, 3, 4. Okay, in that section for more detail. Okay, and next one is that we will talk about the Earth magnetic field lines. Okay, what is going on in our planet. Okay, next one is magnetic flux. Okay, is the magnetic field per area, and the next one will be a little bit miracle. Magnetic field from current carrying conductor. It's another name is that it's the Ampere law or something like that. The next one is magnetic force of current carrying conductors. If you have two conductors, how could we find the attractive force of those two conductors or the long straight wires? The next topic is magnetic force between two conductors. Okay, this is the magnetic force on current carrying conductor. And this here is the force on two conductors. Well, another one is the torque. Okay, torque is the product between, torque is actually the moment, right? Torque is like the product between force and distance, right? So torque on a current loop and solenoid will be considered in this seventh section. And once you get to know the torque idea, and there is a classical device, okay, that applies the torque principle in this section, and that device is known as the Convenometer. I think you may have never seen Convenometer in your life because you are in a new generation, but Convenometer was quite popular during my grandparents, grandfather generation. Okay, yeah, but nowadays it's not popular. It's not widely used at all because you can go to the electricity shop, okay, to the electrical shop, and you just pay 300 or something like that. You can get a good multimeter, and multimeter will serve for many functionalities by Convenometer. Okay, and yeah. So what I mean is that nowadays Convenometer is not widely used. Okay, it's the ancient apparatus to measure current, voltage, the resistance. Okay, yeah. But nowadays they have digital multimeter, which is very useful. The accuracy of the measurement is high. It doesn't consume so much electricity. You just use only battery. The size of the multimeter is acceptable. It's not too big. Okay, we can carry it by using one hand. Okay, once we know the application of torque in terms of Convenometer, we will see another application of the torque in terms of direct current motor. Okay, we insert the direct current to the motor and we get the torque of that. Okay, something that is still related to the torque is the following. We have the induced current, we have induced electromagnetic force. Once you put the torque onto theรับอันนี้ให้ได้ครับเดี๋ยวส่งให้ครับผมเอาใส่คลาสรูมให้เลยใช่ไหมครับตอนนี้ใช่ไหมครับหรือว่าโอเคได้ครับคือผมก็ไม่ทราบว่ามันจะหมดวันนี้นะครับผมก็นึกว่าบทที่1จะไม่จบง่ายๆเดี๋ยวเอาใส่ให้เลยครับงั้นครับมีแล้วครับมีครับแต่ผมว่าผมเอาใส่ให้คุณด้วยก็ได้ครับเดี๋ยวว่าขาดหายไปครับผมก็เพิ่งทราบว่าบทที่1จบแล้วง่ายๆอย่างนี้เลยครับwhat is that physics for right physics M605 right 8 onlineนะครับก็กำลังแนะนำนะครับว่าบท2ของเรานี้จะพบอะไรบ้างครับจะพบอะไรบ้างก็มีเยอะแยะนะครับแล้วก็บท2เราจะคำนวณกันเยอะครับคำนวณค่อนข้างเยอะครับต่างจากบท1ครับบท1ที่ไม่ค่อยมีตัวอย่างในการคำนวณนะแต่ว่าบทนี้นี่คนละเรื่องเลยครับจะหนักมากนะครับจะมีการคำนวณเยอะมากครับก็ค่อยๆว่ากันไปทีละสถานการณ์ครับเพราะว่าโจทย์ว่าไปตามสถานการณ์บางสถานการณ์ก็มีหลายโจทย์ด้วยนะครับใช่ไหมผมพยายามคัดเลือกเข้ามา Magnetism and Electricity also for M604 ไปแล้วนะครับส่งไฟล์ไปที่ Google Classroom ให้แล้วครับเดี๋ยวตอนท้ายก็จะสรุปไฟล์ Good Note อะไรให้ด้วยครับโอเคsorry for that Yeah, right. No, this is for put the torque onto the generator, and we get the induced current, or you can see the a loop of inductor. Okay, and we will talk about Faraday's law of induction. Okay, we will use his law to determine something in physics, and we will see the actual application of the idea by Faraday, and this device is known as electric generator. This is the device that will give us the electricity. You can see it in every electrical power plant. Okay, โรงไฟฟ้าครับจะมี generator ทั้งหมดนะครับ Okay, and we will see other application of the induced EMF principle at the end of this chapter, and these 13 topics would be handled soon for you in chapter number 2 or second chapter. Okay, let's talk about the first quantity. Otherwise, we cannot go well to the next section. There are many ways to describe magnetic field. Magnetic field is the abstract entity. Okay, you cannot see the magnetic field by eyes, but you can get the inference of magnetic field. Okay, you may be the person who is special. You can, I don't know, maybe Wolverine or something. The guy in X-Men cinema or something that may have ability to see the magnetic field, but for a human, the general human being, we cannot see the magnetic field, but we can realize that there is magnetic field. Okay, even we don't see it by eyes. Okay, the magnetic field is a region or of space in which magnetic force can act on other magnets, act on electric current or moving charged particle. And this is the definition of magnetic field. Okay, it's not visible. It's a region of space. Magnetic field is the field of force that causes a force on material like iron if we place it. If it is placed in the vicinity of the field. What is this sentence then? Okay, you may not be able to see the magnetic field lines on the magnetic field, but you can see this is the region that has magnetic field. You can get this picture if you know fire, right? Or the powder of iron. Okay, คุณรู้จักตะไบใช่ไหมครับเอาตะไบเป็นตะไบเหล็กครับก็จะได้เศษเหล็กเล็กๆนะครับ Okay, you get the tiny piece of iron. Okay, but this is million piece of iron. If you throw this iron powder or iron fillings around this is the permanent magnet bar. Okay, there is north pole, there is south pole. We will talk about north pole and south pole later. But you cannot see the magnetic field by eyes. But if you throw or leave the iron powder, okay, the magnetic field lines will arrange all the powder in a tidy manner like this. Okay, and what you can see is the traces of the several iron powder. Okay, and with this experiment, okay, let's go further. We have a north pole, and here we have south pole. The magnetic field line, we start from the north pole to the south pole. Okay, in every line like this. Okay, this is visualized by using the iron fillings. Okay, you have the simple form of the magnet bar, right? Permanent magnet like this. But let's go to the horse farm. Let's talk about the horse. You know that once the horse was born, he doesn't have the shoe at all. But for some scenario, if we want to use the horse in a spatial terrain, the feet of the horse may get trouble. Okay, may be in a in a dangerous situation. So human developed an iron with the same shape of the feet of the horse, and they leave it like the shoe wearing, like the human wearing shoe like this, and this iron is known as horseshoe magnet. But the horseshoe is not always magnet. Okay, they just produce a magnet like this, and of course at the end of the horseshoe magnet there will be two poles, right? This is the north polarity, this is the south pole, right? So the magnetic field line, we start from the north pole to the south pole like this. Let's move to the next one. A magnetic field is a picture that we use as a tool to describe how the magnetic force is distributed in the space around something magnet. Yes, of course. Even we cannot see the magnetic field, we use a special agent like iron fillings, tiny piece of iron fillings, as a tool to describe how the magnetic force is distributed. Okay, you can see the distribution of magnetic field lines. แล้วผมขออนุญาตถามคำหนึ่งครับว่าทำไมการทดลอง3รูปนี้เขาใช้ผงเหล็กโลหะขนาดเล็กทำไมเขาใช้ผงเหล็กโลหะขนาดเล็กทำไมไม่ใช้อย่างอื่นครับเช่นใช้เหล็กก้อนใหญ่ๆเป็นเหล็กกลมๆเลยดีกว่าอะไรอย่างเงี้ยทำไมต้องใช้เป็นผงเหล็กมีคนไหนตอบได้ไหมครับใช่ครับเพราะว่าคือ magnetic field มันก็มีแรงกระทำที่ไม่มากนะครับถ้าเราไปใช้เนื้อมวลเหล็กก้อนใหญ่ๆมันก็จะไม่จัดเรียงไม่สามารถมีความแรงของสนามที่จัดเรียงตัวเนื้อเหล็กก้อนใหญ่ๆได้ครับเขาก็เลยใช้ผงของเหล็กเล็กๆนะครับโอเคไหมคือตัวเหล็กอ่ะมันมีเอฟเฟกต์ต่อสนามแม่เหล็กอยู่แล้วแต่ว่าถ้าตัวเหล็กมันใหญ่ไปมวลที่แรงดึงดูดของโลกมันก็จะฟิกให้ตัวมวลเหล็กนั้นไม่สามารถเคลื่อนย้ายไปมาได้ง่ายใช่ไหมครับพอมวลมันเล็กนะครับแรงอื่นมากระทำมันก็สังเกตเห็นได้ง่ายครับเขาจึงจำเป็นต้องใช้ผงเหล็กเช่นนี้นะครับโอเคlet's talk about our story. Magnetic field is actually the vector field. Okay, it's a vector quantity that describes the magnetic influence of electric charge or even the magnetized material. What is that? It's the material that stay in a region that has a strong magnetic field, and that material may change their property from that reservation. Okay, when you keep it in that area, that material may change their orientation of the polarity inside the molecules, and they can become another magnet. But even it's not a permanent magnet, but it has some magnetic field effect for a certain time, and that's called magnetized material. Even it's not permanent magnet, but it can have magnetic field for a period of time. Okay, magnetic field lines are the trajectories that a non-magnetic monopole would follow when placed in the magnetic field. So, okay, it means this one. You throw away the iron fillings and you can see the magnetic field lines. Okay, even there is magnetic field line. If you don't throw the iron fillings, you cannot see whether there is magnetic field line or not. So iron filling is used as the medium to represent the magnetic field lines. Okay, let's take a look at another figure. You have here the permanent magnet bar, right? There are two poles, the south pole on the left, north pole on the right. And the physicists create the model of the magnetic field line like this. The magnetic field line will start from the north pole, and it has an arrow pointing in this way. Okay, the curve of the magnetic field line may not be the straight line. Okay, it's the curve V line like this. It's a curve, right? If you don't believe in the blue one that was created by physicists, you may use your compass. You know compass, right? Compass เข็มทิศนะครับโอเคไหมเข็มทิศ If you have the compass, you may lay down your compass at this location, and the end point of your arrow in the compass will represent the magnetic field line at that location. If you leave the compass in this area and the magnetic field line are pointing in this way, you will get different direction at different location on this magnetic field line. Okay, and that's why the physicist has created the magnetic field line definition like this. Okay, let's talk about the property of magnetic field line. What can it be and what can't it be? The magnetic field lines never cross. What is that? It means there will be no intersection or touching point between this line and this line. Okay, these 2 or 3 lines will have no touching point. Okay, we have no intersection. Another one is the density field lines indicate the strength of the field. So what is density then? Density, like, as you know, density is the mass, right, per volume. For example, the water, 1,000 kilogram per 1 cubic meter, right? 1 cubic meter. But the density of the magnetic field is done by is the ratio between the number of magnetic field lines per area. Okay, and that's the meaning of density. Magnetic field lines are continuous and do not stop and start and stop anywhere. What does that mean then? You cannot say this is the magnetic field line and then you cut another one and cut this area. No, it's impossible. The magnetic field line should be continuous and smooth like this. Even it's not straight line, it should be smooth like this. And magnetic field sources are essentially dipolar in nature. What is that then? It means it has the North Pole and South Pole. Okay, it has both poles in a certain magnetic field bar, permanent magnet bar. The direction of the field is required. Okay, once you draw the magnetic field line, there should be also the arrow of the magnetic field line. You cannot draw the curve and without any arrow. Okay, that's the notation, regulation in physics. Okay, in physics. The next one is magnetic field lines can be visualized quite easily in the real world. Okay, for example, by dropping the iron fillings around. Okay, we can measure the magnetic field lines by throwing the iron fillings or the tiny pieces of metal or iron. Okay, the strength of the field is proportional to the closeness of the lines. Okay, if you are close to the if you have these magnetic field lines closer to this one and this one is closer, it means the strength of this magnetic field is greater. Okay, is increasing. And magnetic field lines follow the superposition principle. Well, in electricity we have also the principle of superposition for many things, but in vector degree we have superposition principle also for the magnetic field lines. What is that then? Let's take a look at this one. Let's take a look at this figure. We have two permanent magnet bars. The first one on the left hand, the second one on the right hand. And of course, according to the conventional of drawing the magnetic field lines, magnetic field lines start from the North Pole to the South Pole, okay? And it should have arrow. You can see that these lines don't intersect each other, okay? And the magnetic field line can even go in this way, go another way, but it will not reach its own South Pole at all. Only this component, okay, maybe half of that, will return to the South Pole. And on the right side, we have the magnetic bar also, and we have the North Pole on the left, and South Pole on the right. And of course, North Pole is the location where the magnetic field line emerges, right? The magnetic field line starts from North Pole like this, to the South Pole. And it can even generate a magnetic field line in this direction. Okay. This is the individual property of each magnetic bar. But if we move those one of these magnetic bars, permanent magnet bar, to be closer together, to be closer to each other. Before that, we have the magnetic field lines starting from the North Pole. We have the magnetic field line coming to the South Pole in this way. And once you move them to be closer, this line and this line will coincide to each other. This line will coincide with each other, and this will coincide each other. And that's why we have here a smooth way of magnetic field lines for different layers. Okay, and this is known as superposition. Okay, you combine two parts of the magnetic field lines, okay, to get a smooth and continuous line like that. Okay, when we are talking about the magnetic field in electromagnetics, there are two quantities for that share the same name magnetic field, but we would prefer to differentiate one from another one by using a specific name. But you can also refer magnetic field to the letter H. You can also say magnetic field as vector B, okay, because it's also magnetic field. Both are magnetic field. What is H then? H can be known as magnetic field, but for specific purpose, we would say the magnetic field strength. Okay, magnetic field strength is like the current per distance. Okay, and that's why we get the unit A by M. Okay, A ampere by meter, and B is the magnetic flux density. You can say that B is magnetic field. It's acceptable, but to differentiate them, to differentiate B from the letter H, we would say this is the magnetic flux density. Okay, but actually both can be called as the magnetic field. Magnetic flux density is valid for only B. Magnetic field strength is valid for only H. The unit of the magnetic flux density is what you may have already seen in the last chapters 2 times, right? It's the Tesla, right, which is the unit of the magnetic flux density. And in terms of plain SI quantity, we are going to say that Tesla is kilogram per second square and ampere. Okay, we got to know the model, the basic idea, the property of magnetic field already. What about the strength of magnetic field on Earth? Okay, on Earth we have the magnetic field about 5 times 10⁵. Okay, which is not strong, right? It's not strong, but there is there in on Earth, in the air. Okay, everywhere on Earth. Now we arrive at the magnetic field analysis we have the magnetic flux density, okay, magnetic field strength H, magnetic flux density B are vector quantities. So that's why we need to have arrow on top of that. Okay, if there is here magnetic field line, magnetic field lines like this, and if we throw away the positive charge, okay, we're going upward like this, and if we throw away the negative charge to go upward like this, what is going on then? มันครั้งนี้มันเป็นออนไลน์เนาะเดี๋ยวผมจะหมุนมือให้คุณดูยังไงนะครับก็หวังว่าสัปดาห์น่าจะเข้าใจมั้งเนี่ยหมุนมือขวานะครับ okay in order to find the direction of the outcome, okay, we have magnetic flux density pointing in this way from left to right, and we let the positive charge, let's say positive charge is not proton, okay, in reality proton cannot go out of nucleus easily like that. Let's say this is the helium-4 okay, helium-4 nucleus of the helium. We throw away 2 atoms, okay, and that's why we get only the nucleus of helium-4. Helium-4 is a stable nucleus. If you get into chapter 7, well, okay, even we are in online, I need to let you know by using, I don't know how we determine the force, right? This is the VB. Okay, this is the velocity direction of that vector, the velocity of the positive charge, and here is the okay, this is the vector B, right? And you need to curl or rotate your fingers from V to B, right? Your 4 fingers starts from the direction upward like this of the velocity, and you rotate this one by using your right hand 4 fingers to vector B, which is right here, okay, the green one. And after that you can see your thumb direction, the first finger direction. You can see that your thumb direction will point in this way, and this is called vector F. The force will take place to this positive charge in this way, and once you let it go, it will not go upward easily because there is another force to bring it to this way. So it's going to be a projectile or curve motion like that. Okay, if anyone who is in if there's anyone who is in Streamlab โอเคผมถ่ายทอดมือไปที่ช่อง Streamlab ได้นะครับแต่ว่าที่ซูมมันมองไม่ค่อยมันไม่ได้ครับโอเคไหมก็ใครที่ Streamlab ก็ดูนะครับ you can rotate your 4 fingers from vector V to vector B, and your thumb direction will be this way, okay, and that's why we get the F vector direction like this. Okay, in terms of mathematical expression, we can say that F could be found from Q V cross B, right? Q V cross B. So this is the cross product. Yes, okay, it's cross product. So what is cross product? Then cross product is the way you rotate your 4 fingers, right? From V to B. Here is the implied usage of the cross product. Okay, but if you want to see the cross product in detail in mathematics, we're gonna start a new page like that. Before we go to the cross product, we have to talk about dot product. Okay, is there any one of you who get the idea about cross product or dot product? มีใครสอบเตรียมตัวฟิสิกส์โอลิมปิกไหมครับมีคนไหน รู้จัก cross product dot product อยู่แล้วบ้างครับก็ถาม604แล้วครับผม Physics Olympic so I think you would have some background about dot product and cross product, right? But for the rest of the people in this class, I think you may not know well, right? I have asked M604 and they have no idea. They had no idea about cross product. Okay, I will let you know right now. Okay, before that, you may consider vector in 3D. Okay, vector in 3D. What is that? Then we have the Cartesian coordinate, right? We have the Cartesian coordinates. This is the z-axis, right? And here is the x-axis, and here is the y-axis, right? Okay, let's talk about first unit vector of this one. Okay, unit vectors can be here along the x-axis, but the length here should be only 1. Okay, and this one is known as unit vector I. Okay, I is the unit vector. Okay, another one is the vector. Let me no. Let me change color a little bit. Say this one. Okay, another unit vector is this one. Okay, it's short, it's not so long, and because the length is only 1, this one is known as unit vector J. Okay, what's J? J is the unit vector. Once we say unit vector, means the vector that has the length of 1. Okay, the vector that has its length as number 1 or unity, and that's why we call unit vector. Okay, the unit vectors may not be only ijk. It can be any vector that has its length as number 1. Okay, I just introduced you to basic 3 unit vectors first along the x-axis นะครับถ้าออนไลน์ก็จะเป็นภาษาอังกฤษเยอะๆหน่อยนะครับเดี๋ยวพอไปห้องจริงเดี๋ยวผมก็จะพูดภาษาไทยให้เยอะๆครับแต่ถ้าระหว่างภาษาอังกฤษคุณไม่เข้าใจไงคุณก็ยกมือถามผมทันทีนะครับ Okay, the next one is the unit vector along the z-axis, and the length here should be also number 1. All right, length here is number 1. It's known as vector k. So vector k is the unit vector along the not x-axis. This is y-axis. I'm stupid. I forget. Okay. Oh, y. Okay. Yeah, y-axis. And here is the result of the z-axis. Okay. You have 3 basic unit vectors, right? But for any vector, for example, like this, x, y, and z again. If you have vector a like if you have vector a like for example 132, okay, vector I minus 3j and plus 2k. What is vector a then? How could we build up the vector a? So you need to go along the x-axis by 1. So this is single 1, and you have to go along the y-axis by minus 3. So this is the positive y, right? Positive y-axis. If we want to go to negative because of this minus sign, we have to go to the left, right, by 3 units, like this. Okay, 1, 2, 3. And we need to go to the y-axis, positive y-axis by number 2. So we go up by 2, only 1, 2. Okay, and unit vector A will be this one. Okay, starting from the origin. The origin is 0, 0, right? There is no component at all. And here is our destination for the vector A. And this one is called vector A. Okay, you know how to build up the vector first in 3-dimensional system or Cartesian coordinate. If we have another vector, which is vector B, for example, it's minus 6i plus 5j and minus 13k. Okay, you know vector addition, right? Addition. What is that then? If you look for A plus B, what is the result then? Okay, you just draw. You just say it's vector I, because A is this one here, minus 3j and plus 2k, and vector B will be the second vector, right after the plus sign. We write down here the plus sign, and we copy vector B to this location. Minus 6i plus 5j and minus 13k, right? So the next step for derivation is this one. Okay, we combine the I. We have I and minus 6i, right? So this is parenthesis. Okay, we have minus 6i and minus 3j and plus 5j and 2k. Okay, let's talk about the k component. Plus 2k and minus 15k. You can see that you get 1 minus 6 of the vector I. You get minus 3 and plus 5 for the j component, unit vector along the y-axis, and you get 2 minus 13 for the component along the z-axis, unit vector k, right? And of course, you can get the final result as minus 5i and plus 2j, right? And you get minus 11k, like that. Okay, this is the vector addition. Let's talk about the dot product. Before we go to cross product, we, of course, you know subtraction, right? คุณต้องการให้ผมเอาเวกเตอร์ลบกันให้ดูไหมครับหรือว่าเวกเตอร์ลบกันก็ไม่ยากอ่ะก็เปลี่ยนแค่ตรงนี้เป็นบวกเป็นลบนะครับต้องการให้ผมทำให้ดูไหมครับถ้าไม่ผมก็จะไปคูณแล้วนะโอเคนะครับมันไม่ยากจากต่างจากนี้มากครับโอเคบวกเป็นก็ลบเป็นครับโอเคป่ะ The dot product is the first way for vector multiplication. Okay, vector multiplication can be decomposed into ways. Okay, the first way is dot product. Okay, we have here dot product. Another one is the cross product, which is what we are talking here, the cross product for velocity vector and the magnetic flux density vector. A dot product means if you want to find A dot B, it means you just multiply like this, I minus 3j and plus 2k, 2k, and dot the second vector, which is this one, minus 6i plus 5j and minus 13k. Okay, the way to do this is the following. You just pick up the coefficient in front of I for both components and multiply them together. You have number 1, you have minus 6 for the second vector, and after that you place the plus sign. And let's talk about the coefficient of the second component j, right? And we have here minus 3 and 5. So it's, it's the minus 3, negative 3 and 5. Can leave the plus sign in between. We have number 2 and minus 13. Number 2 and minus 13. All right. And after that, you get minus 6, minus 15, and minus 26. One more page. Oh my God. No. This one. Okay. And yeah, we can combine them. It's 32, right? 32 or 47, right? Minus 47. And that's the dot product. Vector addition will return vector to you, but dot product will return the scalar quantity to you. Let's go to the destination, and that's the cross product. Okay, if you have any problem about the dot product, just let me know. If you don't understand, or if you want to, have one more example, just let me know. Product, right? เวลาจะหมดนะครับผมขอรีบนิดนึงนะครับ Okay, what is A cross B then? Okay, we don't use the dot product. You just form up the dot product by determinant. You know determinant, right? Determinant is the operator that is used for square matrix, right? We have here 3 by 3 matrix. In the first row, you know the row, right? Row is in this way. The first row, second row, the third row. This is the first column, second column, the third column, right? In the first row, we laid out the unit vector, and unit vector along the x-axis, unit vector along the y-axis, unit vector along the z-axis. That's the first row. In the second row, we will lay out the component of the first vector. The first vector for us here is vector A, and we laid out not the whole vector, we laid out only the coefficient. The coefficient of the first vector I minus 3j plus 2k is number 1, number 3, minus 3 and 2. Okay, that's the second row. In the third row, we're gonna write out the coefficient of the second vector, which is minus 6, 5, and minus 13. We write down here minus 6, 5, and minus 13. And after that, you have to compute by hands. Okay, let's do the determinant ขออนุญาตจบตรงนี้แล้วก็จะปล่อยแล้วนะครับโอเคมาก็จะหมดคลาสแล้วนะครับเดี๋ยวมันค้างไว้เดี๋ยวมันมาต่อยากนะครับ Okay, we have minus 3 and minus 13 and unit vector I, and we have plus j and 2 and minus 6, right? So we have number 2, minus 6 and j. All right. What about k? We have k 1, 5, right? So it's plus 1 and 5 and k. That's the way to go down, right? The way to go up will post the negative sign in front of it. If we go down, it's become positive. That's why we say positive sign here. If we go up right like this, it's going to be negative. So we will write down negative. What is that? K minus 6 minus 3. So minus 6 minus 3 and unit vector k. Okay, and what else? We have 5 to I. So it's going to be minus 5 to and I. Okay, what else? we have minus 13, 1j. So minus 13 and 1 and j. Okay, let's combine everything. You would get 39i, right? 39i, and you have another i here, which is minus 10i, and you have j here, minus 12j, and you have here minus 13 and plus, right? We have an additional negative plus 13j. And what about k? We have 5k plus 5k and negative, positive 18 and negative 18 at the end. So minus 18k. And yeah, there you go to 39 minus 10 for the component I. There you go, plus minus 12 plus 13 for the component j. There you go to 5 minus 18 for the last component z or k, right? And you can get the final result, 29 along the x-axis, and plus 1, right? Plus j, and here you get negative 13k. Okay, all right. Let me check whether the answer is correct or not. Otherwise, you get the wrong. If there is something wrong, you may ask me later. You will get confused later. Let me check for you. A is, what is that? A is 1 minus 3, 2, right? 1 minus 3 and 2. The second vector is minus 6. And 5 minus 13. And we see the cross product. It's 29, 1 minus 13 is correct right here. Okay, that's all for the cross product, right? You get to know the cross product, which is very important if you go to the bachelor degree. They are going to teach it. If anyone didn't write down your name, please don't forget to type your name in the chat box in the Zoom meeting, or even you are in YouTube. Okay, please write down your name. Otherwise, you will get missing score in the class attendance. Okay, I don't know where is the first person. Who is the first person? M605. I think this one, right? Goff Thanakorn would be the first person for MC5. Okay, see you on Friday. พบกันวันศุกร์เช้าครับว่า today there will be no homework. Okay, bye bye ครับ สวัสดีครับ สวัสดีครับ สวัสดีครับ605 This is the here this one. Yes, and we send it to this person. 3. And this one too. This is M605. 605. M605. M605. Yeah, like that. And we need to quit the zoom. Finish. We stop the stop this. And this one. Oh no. And yes, of course, it's going to be. Yeah, we stop the stream.